Solve quadratic equations by completing the square. So, first off, let's say we were given x squared plus 6x minus 2 equals 0. The first thing we want to do is pull the 2 to the other side. So we want to leave just the variables on one side and 2 on the other. Then we want to ensure that this number is a 1. If it's anything besides a 1, we need to factor it out front. We'll get into examples that have that in a minute. The idea is we're going to add some number to both sides of the equation to make it so this is a perfect square trinomial, but by adding it to both sides, we don't change the function because it balances it out. It would cancel out anyway if we were to subtract it from both sides. The way we find that number, I'm going to refer to this number as c, is equal to b divided by 2 squared. Remember a, b, c? So we say 6 divided by 2 squared is equal to 3 squared, which is 9. So I'm going to add 9 to both sides. Notice this now factors to be x plus 3. This side combines to be 11. Since this is x plus 3 two times, I can write it like this. This will always happen. We picked this number specifically to get this type of a situation, because what it will now let us do, like in the last video, is solve for x. So subtract 3, x equals negative 3 plus or minus the square root of 11, which happens to be decimals, but it is 2 answers. Completing the square is a nice option when factoring doesn't work. So say, for example, we have x squared plus x minus 3 equals 0. Once again, factoring doesn't work on this one. So we're going to add 3 to the other side. And we're going to add some number to both sides of the equation. C in this case is 1 divided by 2 squared, because this is a 1, which is 1/4. So I'm going to add 1/4 to both sides. Fractions make it seem a little intimidating, but here's how this happens. This number is always half of b. It will factor to always be half of b. So this will factor to be x plus 1/2 squared. To add these two together, 3 is the same thing as 12 over 4 plus 1 over 4 makes 13 over 4. Square root both sides, x plus 1/2 equals plus or minus the square root of 13 over 4, which, if we break up that square root, it's square root of 13 all over 2. So, x equals negative 1 plus or minus the square root of 13 all over 2 when we minus the 1/2 to the other side. So on our third example, let's touch on the case where we don't have a 1 for that front term, which we have to have. So first off, getting the 5 to the other side of the equation. So here's what happens. We factor out whatever the number is. So factoring it out makes it look like this. And if we're going to add some number on this side, we're going to add that same number on the other side. But notice the number's in the parentheses, so eventually it will be times by 3. So the idea is we also have to times 3 to the number we add on the other side. That number's the same steps we've done in the past problems. So we say this divided by 2. So c equals 4 divided by 2 squared, which is 4. So I add 4 to both sides. This factors to be x plus 2 squared. So it's this number divided by 2 and then squared. 5 plus 12 gives us 17. Divide both sides by 3. And x plus 2 squared equals 17/3. Square root both sides. x plus 2 equals plus or minus the square root of 17/3, which if we want to rationalize the denominator, we times top and bottom by square root of 3. So x plus 2 equals plus or minus the square root of 51 all over 3. Subtract 2, and we end up with this is our final answers. -2 plus or minus the square root of 51 over 3. So the big thing in completing the square with this example, you have to have a 1. So you factor out whatever that number is in front, even if it creates a fraction here. You'll go through the same process of dividing it by 2 and squaring it to be the numbers that's added. This will always be half of whatever that number is when you have a perfect square trinomial.